All right, let's look at the homework hints for the Lesson 9 practice problems in Unit 4 of Algebra 1 with Illustrative Mathematics by Imagine Learning. So this is number 1. Functions R and D give the height and feet of a toy rocket and a drone t seconds after they're released. So notice that the rocket is that arch or upside down parabola, and the drone has that flat section where it's able to stay at the same height and go straight for a second. Anyways, highlight those functions, and then it says at 3 seconds, the toy rocket is higher than the drone. How would we say that in function notation? And so we're talking about right here, these two little dots at 3 seconds. So how would we say that the rocket is higher than the drone in function notation? And so we would say R of 3 is greater than D of 3. The rocket is bigger than the drone. The rocket is above the drone. The rocket is higher than the drone. There it is in function notation. The second one, at the start, the toy rocket is 25 feet above the drone. We'd say T of 0. Oh, I just noticed I put the wrong letter. Rocket is the drone plus 25 feet. So at the beginning, the rocket is the drone plus 25. And so R of 0 equals D of 0 plus 25. A of T is the average high temperature in Aspen, Colorado, T months after the start of the year. M of T is the average high temperature in Minneapolis, T months after the start of the year. The temperature is measured in degrees Fahrenheit. So they want to know which function had the higher average rate of change between the beginning of January and the middle of March. What does that mean about the temperature? And so we're really only talking about this small interval right here from January, the beginning of the year, through the middle of March. And notice that we've got counting like 1, 2, 3, 4 along the bottom. So this over here actually starts at month 1 or January. So it's kind of weird because it doesn't start at 0. Anyways, we have to estimate those starting points. So my students and I decided that that looked like 0.25. It was like about halfway up to 30. If you called it 27 or some different number, totally close enough. And then we thought that this one looked about midway between 30 and 40, so we called that 0.35. So these here are both the starting points of each function. That one goes to that, and that one goes to that. Let's use a different color for that. Okay, then they both have the same ending point on that interval. So what did we call this dot right here? We said that that looked like it was around 3.5, middle of March, and 50. And so notice that we used the 3.550 in both as an ending point. Then we're doing the difference of the outputs over the difference of the inputs to find the actual rate of changes. And really just looking to see which one has a greater average rate of change. We noticed that Minneapolis has a greater rate of change on that interval. Well, couldn't we just say that Minneapolis is above Aspen? And so we could have said that this starting point to this starting point is our dashed, and it goes up more. It goes from a lower point to a higher point. This one goes from the higher point to that same point. So we could say the dashed line has had a greater rate of increase just from noticing that it started lower and it ended up at the same thing. So here's like a way to show it algebraically. You also could just explain in words that you notice that it has a lower starting point but ends up at the same place. So obviously it must have a greater rate of change. Next is asking you which of the statements are true, and there's a typo in the text. Go ahead and cross out letter C. So is f of 0 greater than g of 0? So when you go look at the point 0, we see that this function here, f, is below g. And so f of 0 below g, so this is not true. And then there are two values where f of x equals g of x. We do notice that that is true here and here. And so that one was a yes. And then f of -3 is greater than g of 4. You could actually get the values and plug it into the inequality, or just notice which function is higher. Sorry, not better. All right, the 3 graphs represent the progress of 3 runners at a 400-meter race. You're just going to basically find which one is which based on the descriptions and match those. Who won the race and explain how you know. Next, we're going to be filling in a table of values based on squaring the inputs. And so to fill this in, we're saying to ourselves, what would that input times itself give me? And this is actually going to be the parent function of all parabolas that we're going to be working a lot with next semester. But so we would say to ourselves, if this is a square and I'm doing 0 side length times 0 side length, what is 0 times 0? What if it was a 1 side length, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and you're getting the pattern. Okay, so this is called side length squared. So we write the function as x squared. If the function was a of s, using s as the side length, we would write s squared. But they want us to use x. And then go ahead and plot those points. You should get half of a parabola. Why don't we get this other half of the parabola? Because there's no negative areas. And so in this case, the acceptable domain starts at 0 and goes to the right only. Last but not least, they want us to take this function and plug in an input to get an output, and plug in an output to solve backwards for the input. So hopefully, since this is a review question back from lesson 5, hopefully this one is no problem for you to try on your own and check these answers.